All right, 8b. Once again, the issue here is factoring. I got to factor first. So 2 over, well, I look at the denominator, that's a difference of squares, x squared minus 1. So this is x minus 1, x plus 1, and you want to be on the lookout for the difference of squares factoring. It's going to show up frequently. Okay, so now between the two terms, I see that there's a shared factor of x plus 1, because again, remember, I'm going to keep saying this, x is not a factor of this expression. Okay, it's x plus 1, it's an addend. Okay, the only way it becomes a factor, the only way I can consider it common is if an x is multiplied by other factors. So x plus 1 is the common factor, if you will, in the denominator. So I can write down a representative of that. The only other factor in the denominator is the x minus 1, so I have to include that there. Now, in the first term, the denominator is already complete. I don't need to do anything to it, so the numerator is complete. On the second term, the denominator isn't. I needed to include the x minus 1 term. So I would multiply by the bottom and the top, and that's going to give me 2 plus x plus, oh sorry, it's the x minus 1 that's not common here. So x minus 1 there. Now putting that together, I'm going to end up with x. 2 minus 1 is positive 1 over x plus 1, x minus 1. Now, this really is the type of question that we've been building towards, because finally you're going to see a good solid example of this. Now that you've combined the numerators together, okay, I look at that and say, well, can I factor x plus 1? Truth is, no, you don't, but you don't need to here. Notice that that is a shared factor to the x plus 1 in the denominator. So that will be equivalent, okay, to, I can cancel those guys out. They divide them out to get 1. That's equivalent to 1 over x minus 1, which I can then make equal as long as I state x cannot be allowed to equal, in this case, negative 1. Okay, so that deals with the removable discontinuity, or that factor that I can get rid of. Now I'm stuck with this x minus 1 term in the denominator, and I just want to state that non-permissible, x cannot equal 1. That's a really good question.